In this video, we'll solve a problem related to the Lamis theorem here. Okay, this is problem number 5 here. Before also, like 4 problems we solved here related to some string applications, weight applied onto the string at different points, and we have to calculate the reactions. In the previous problems, we calculated. Also, the sphere problem, one sphere problem we are we're done here. Okay, the sphere it sits on a triangular groove, and what are the reactions and how the unknown values we found that is the previous 4 problems. Now again the next problem is problem 5. It is also the application oriented problem, and there are 2 spheres are there, and these 2 spheres related to sits on one more cup. Okay, this is the problem, and to this problem first we will understand how we have to analyze and how the sphere sits on the cup, what are the reactions and everything, and after that we will apply the Lamis theorem. Okay, and try to solve the unknown values, or what he is given we have to try to solve that. Okay, first we will read the problem, then we will go through thoroughly here. Okay, first I'll read the problem. There are two equal heavy spheres of 50 mm radius. Okay, you can see here this is a sphere, this is one sphere, these are 2 spheres. This is sphere, and this is sphere 1, sphere 2. There are 2 spheres, 2 equal heavy sphere, the heavy spheres of 50 mm radius. What is the data? We'll write one by one. Data, that is the radius of sphere. Equal to 50 mm. 50 mm radius are in equilibrium. They are in equilibrium. Within a smooth cup. Within a smooth cup of 150 mm radius. 150 mm radius here. Okay. This is 150 mm radius. Just copy this one. This is 150 mm radius. It means these 2 spheres, heavy spheres, okay, heavy spheres of radius 50 mm, each having 50 mm radius, and they sits onto a smooth cup. This color is, this is a cup. This is cup here. On a smooth cup of, what is the radius of the cup he is given? 150 mm. 150 mm. It means cup radius. We can write it. Cup radius is 150 mm. 150 mm radius. It means from here to here the radius. We'll explain later. Okay. So now what he's asking? Show that you have to show that the reaction between the cup of one sphere. It means the reaction of between the cup and the sphere, any one sphere, the cup and the any one sphere is double than that between the 2 spheres, that is 2 spheres. So you have to prove that the reaction between any one cup and the cup and any one sphere, here one reaction is 2 times than that of the reaction between the spheres. Here you will get some reaction that we will analyze here. This is how the problem he is asking. He is given 2 cups, heavy cups of radius 50 mm. He is given. They sits onto the smooth. These are 2 spheres. Sits onto a cup. Sits onto a cup of radius is 150 mm. 150 mm. You have to show that the reaction between any one sphere and the cup, is 2 times than that the reaction between the 2 spheres. This is how the problem analyze here. Okay. Now we will go for the diagram here. As you know, this black colors 2 are there. They are 2 spheres. And they sits onto a whatever this is there. This is a cup here. Now we will mark as the center of one sphere is A, center of one more sphere is B. These are the A and B are the 2 centers. The centers of the 2 spheres. Okay, and they sits onto a cup at point D and E. Okay, and the O is the radius of the cup. This is OD or OE is the radius of the cup. The AD or B is the radius of the spheres. And weight, since both are equal heavy weights, their weights are W. The sphere weights are W, and they will be always in the downward due to gravity. W. Okay. Since these two the sphere sits on the cup at point E and D, there is a reaction. There is a reaction R and R. Okay, both are R only, because the weight of the balls are same, weight of the spheres are same. Okay, and contact is at particular point. It means the reaction is the same. It will come R and R. Don't write R1 and R2 and here W1 and W2, because the sphere weights are same, the W is same, W1 equal to W2 equal to W, and because the point of contact somewhere, the reactions are same. Did you get the point? Just once again I'll explain. The two spheres are centers A and B, and the center of the cup is O. And these two spheres sits on a smooth cup at point D and E. And D is the because of these contacts there is a reaction R here. Okay, and the W, the weight of the spheres are downward, here W, here. Okay, this is how the diagram explanation. Just I'll remove the problem here, because we know everything data here in the diagram only, diagram itself. We have to prove that the thing here, what he is given. Just we'll go that. Let first point, two spheres with centers A and B. Centers A and B sit on smooth cup of radius of center is what? Of center is O. Of center O. Did you get the point here? As shown in figure. It means first point, it explains the two centers of the spheres are A and B, and the cup point center is O. Cup center is O here. Okay, the two spheres touch the cup. Next one, where the two spheres touch the cup? At point D and E, right? Two spheres, the next point is two spheres touch the cup at points D and E respectively. Okay, this is the second point here. Okay, let R equal to, what is the R here? R equal to reaction between the sphere, one sphere and the cup. Okay, the reaction between cup and sphere. Okay, this is R. Here there is a contact here between the spheres. The point of contact is C. Okay, the point of contact is C here. Okay, so in the point of contact there is a reaction. That reaction is we taken as yes. We can take it as yes here. Okay, so here one reaction, and here these spheres touch each other, contact each other at point C, as you can see in the figure, at point C, and because of this there is a reaction. To this one there is the opposite reaction. For this sphere there is opposite reaction. Okay, so this reaction we can take it as yes here, whatever yes. Okay, let S equal to the reaction between spheres, right? Between spheres. Be careful here. One R is reaction between the sphere and the cup. S is reaction between two spheres. What we have to prove? R equal to 2 times S. We have to prove a reaction between the sphere and the cup is 2 times the reaction between spheres. Yes, R equal to yes, we have to prove this one here. Okay, now we will go for the geometry here. We will go for the geometry of the figure, and we'll try to prove that R equal to 2 times S here. Okay, from the geometry of figure, from the geometry, we will go first one by one. OD, what is OD? OD equal to 150 mm. OD is the radius of the cup. OD is radius of cup. It is 150 mm, right? He is given 150 mm. How about AD? AD is the radius of sphere. Radius of sphere is 50 mm. AD equal to 50 mm, right? 50 mm. So can we how about OA? OA is OD minus AD. Okay. Therefore, OA is the equal to OD minus AD. OD minus AD, right? OD is how much? OD is the 150. This will be equal to 150 minus 50. That will be equal to 100 mm. 100 mm is OA. OA. So now we calculated OD is 150, AD is 50, and OA is 100. OA is 100. Similarly, come to the right sphere. Similarly, go for that. OE is how much? OE. OE equal to the radius of the cup. Radius of the cup, it is equal to 150 mm. Right? 150 mm. Next, how about BE? BE is the radius of the sphere. BE. BE equal to radius of the sphere, it is 50 mm. 50 millimeter. So, can we calculate OB? OB is OE minus BE. OB is OE minus BE. Therefore, OB equal to OE minus BE. B. Here also you will get same. OE is 100 minus BE is 50. That will be equal to 50 mm. Okay. Remember, OA is 100. Okay. OA is 100. AD is 50 and OD is 50. OD is 150. If you come to the right side, OB is 100, B is 50, and OE is 150. 150. Okay, this we need here. Now, can we calculate the AB? AB how much from the geometry? AB is AC plus CB. AB is AC plus CB. AC is how much? Radius of the sphere is 50, 50. 50, 50, 100. We can calculate. That is also AB equal to AC plus CB, right? AC plus CB. Just I'll remove here. Okay. AC is how much? Radius of the sphere is 50 millimeter. And CB is how much? Radius of the one more sphere is 50 millimeter. This will be equal to 100 mm. Now check that AB is 100, we got AB. This is AB. We got 100. How about AO? AO is 100. We got here AO. This is also 100 mm. Right? How about OB? OB. Here. This is OB. This is also OB. This is 150, right? This is 150. Sorry for that. This is 150 minus 50 is 100. This is 100. Sorry for that. Okay. So OB also 100. Now OA 100, AB 100 and BO 100. Now can I call it as triangle OAB is equilateral triangle? Yeah, we can call, because all three sides are equal. 100 mm, 100 mm, 100 mm. Okay. Therefore, triangle OAB is equilateral triangle. Equilateral triangle. Since all sides are equal, this is important. All sides are equal. So now, if this is the equilateral triangle, so angles are same. Inner angles are same. This is 60, this is 60, this is 60, right? So can I call this one as angle OAB is 60 degree. 60 degree. Right or wrong? That is 60 degree. Now come to the free body diagram to apply the Lamis theorem. To apply the Lamis theorem, we have to draw the free body diagram at point at point A. At point A, apply the first sphere center. You can apply here also, you can apply here also, no problem. But I'll apply here at point A. Okay. I'll write here, apply free body diagram. Free body diagram at point O. At point A. at point A. At point A. Okay. Now I am applying a free body diagram at point A. How many forces are there? One is reaction. It is in this direction. This is first point A. I'll write here. This is point A. Right? At point A, one is reaction in this side. This is R. Okay. Next, one more downward weight of the sphere W. This is 1. This is W. Right? Then here the reaction. Because of this, the reaction is opposite side. That is S. We have taken this one as S here. Right? This reaction. Because this sphere, it will react in other sphere, and other sphere is react in this direction to this sphere. So I can write this one as like this. This is S. This is S. Okay. So this one is S. So three forces are acting at point A. At point A. One is R, reaction R in this direction, and the downward, the weight of the sphere is downward side, okay, direction, and the reaction in this direction. Now apply to these three forces the Lamis theorem, because Lamis theorem is always related to three forces. Now you got three forces, apply here. Before that, we will find out the angles. Right? So with respect to horizontal, 60 degree, because of the equilateral triangle. This, just with respect to horizontal, this is 60 degree. Okay. How about this angle here? This is 90 degree. Right? This is 90 degree. Okay. Now this is horizontal. This is 180. 180 minus 60 is how much? 180 minus 60 is 120. This I can write it as 120, right? Because horizontal is 180. 180 minus 60 is 120. So how about remaining here? Remaining is, this is 90, because perpendicular, 90 degree. Okay, this is how we know only 60 degree. We know only 60 degree from the equilateral triangle. Remaining are, we have to find out. Okay, we have to find out. Now finally, I'll write the only for three forces. How much is the what are the angles here? Okay, what are the angles? Just I'll erase here. Okay. Now we'll go for that. I'll draw one more FBD, one more free body diagram. This is also FBD2, same for that point. This is point A. Here is the reaction. Here is the downward force W, and one more is the reaction between the spheres. Yes. So now tell me, between R and W, how much is the angle? 60 plus 90. 60 plus 90 is, this will be 150. This is 150. This is 150 degree. 60 plus 90. Now between S and W is 90, because they are vertical. I can write this one as 90 degree. This is 90 degree. How about between S and R? S and R is 120 degree. S and R is 120 degree. This is 120 degree. Okay. So first first work out this one, then simplify, then make it the whatever the angles between the three forces. Now apply Lamis theorem to this one. Apply Lamis theorem for above FBD, free body diagram. Okay. Now we will go for one by one here. Okay. So one by one, how much is there? First R. R is the one reaction divided by sine of. We know that this already we solved so many problems in previous videos how to apply the Lamis theorem. Okay. R divided by sine of the angle between other two sides. This is R divided by sine of angle between two sides is 90 degree. 90 degree equal to the W, will go W divided by, this is W divided by sine of angle between other two sides is R and S, in between these two is 120 degree. 120 degree equal to one more force is S. S divided by the angle between R and W. Angle between R and W is that is sine of 150. Did you understood this one? Whatever the force it is acting, divided by sine of the angle between other two forces that we applied. we solved so many problems here. Now just simplify here. R divided by sine 90 is 1 equal to W divided by sine of how much? Sine of 90 plus 30. I think this you know that how to split. This will be equal to S divided by sine of 180 minus 30. Right? 180 minus 30. Okay. Now again simplify. This is R equal to W divided by sine of 90 plus 30 is sine 30. Right? Sine 30. Sine of 30 equal to S divided by sine of 180 minus 30 is sine of plus 30, not minus 30. It is in the second quadrant, the sine and cosec are positive. Second quadrant, sine and cosec are positive, therefore minus 30 also it will be 30. So this will be equal to sine of 30. Sine of 30. Okay. Now again go for next simplification. R equal to W divided by sine 30 is half, 1 by 2 equal to S divided by sine 30 is half. Okay. Now take first one and last one, because we have to prove the reaction between the sphere and the cup is 2 times the reaction between the spheres. Okay. From that R equal to, therefore R equal to S 2 times S divided by half, therefore R equal to 2 times S. This is the final proof. Okay. So this says that the R is reaction between any one sphere and the cup. Any one sphere and the cup is 2 times the here S. Here the reaction between two spheres. Okay. This is the proof he is asking here. Okay.